Hello, my name is Nathanael, and today I would like to show you how to program the Safety Simplifier with the help of the Simplifier Manager. Okay, so now welcome to the software. First of all, we take a look into the settings. You have different possibilities. In general, you can change the language. So right now we have 4 languages. Normally the system default language will be selected, so it depends on where you install it or what's your system language. You can change the color. I like to have it in the dark mode, but of course you can also use the light mode, which is pretty light. You can change the default project folder if you would like to. You can do some other settings, which are mostly not so important. I would recommend to keep that automatically check for updates, because it helps you to always get the new software. Under user informations you can write down your name, your company name, and this will be also used later on the pages if you check them, and also in the report to see who programmed the software. So now we start to make a new project. First of all, of course, we can write down a name for the project. So now you can see the responsible person and the company name is already visible inside here. You can make a small description. For example, system out of 3 simplifiers, 2 E-stops, 1 cabinet unit, for example. Down below you have some settings about the communication. You can disable the radio. That means that you are not able to make an online diagnostic anymore. You can still download projects via radio, but you are not, like I said, able to monitor it. This makes sense, of course, if you have a CAN system or you have a standalone application and you don't want the unit to send out any radio signals. So next you can choose the radio channel. Default is channel 5. You can change also the CAN baud rate, but I guess it's mostly not needed because 125 kilobaud is fast enough for safety. And now there are 2 important values, the timeouts. 1 short timeout default wise and 1 longer timeout. And the timeout explains how often the signal has to be updated on the other side. So if a simplifier don't get an update from a global memory which is used in that simplifier longer than 500 milliseconds, then of course it has to turn off that signal. So that's why the timeouts of course are important, because it's safety relevant. Okay, so let's jump into the hardware configuration. We have different possibilities. First of all, we can check the standard units. So there are a bunch of standard units which are pre-wired. So we got standard units for almost all of our sensors. So for example, if you have a unit for T-guard, it's a guard locking system. You have the power supply on the bottom and the plug for the actual sensor on the top, and all the stuff which is connected here is already pre-wired to the safety PLC inside. So that's of course very useful, and in this case, or in this training scenario, we use 2 times this very simple unit with an E-stop and a push button. So we can go next, write down a name, we call it door 1. We can change the color of the push button, but we keep it blue because it's a reset button. And we add another one, exactly the same, we call it door 2. Yes, so we have those 2 door units. We also add like a cabinet unit. In that case, we use a plank unit, which is like an empty node, and you can program it yourself. We call it cabinet. And in this case, you also can make some settings. For example, you can use an external antenna if you have one. So not all units have the possibility to connect an external antenna. You have to watch out for the RX version. We can disable the CAN bus if it's necessary. You can choose the hardware type. In this case, we have the S16 because we need the 2 relay outputs. And of course, you can configure it as you would like to have it. But in this case, it's a cabinet unit. And And we have no buttons and no plugs because the cables are going through the back to the cabinet directly. Okay, we can jump into the nodes. First of all, node 1, the standard unit. We can see there's already some smaller project. The e-stop connected to pin 2 and pin 4. Also connected to a memory, which is already global. You can see that by the GM number after the memory. If we click it, we see e-stop. We call it door 1. So to get a better naming and a good structure. We can give it a color. So the e-stop function in our world is always golden. Of course, you can choose another color or no color if you would like to. It's a global memory, so it's available in the whole network. And we have to give it a global memory number. So like I said, in our standard units, it's already done, but of course it's good to know how to do it. We got this memory. We do the same thing for the reset. We call it also reset door 1. And yeah, so that's the part which we have to do here. So we can go back to the project overview and go to the next unit, node number 2. We have 2 pages here on the top, or 2 tabs, like in your browser. So inputs and outputs in this case. Of course, I can do more pages if I would like to. For here we do pretty much the same. We call it door 2. The reset also door 2. If we go to outputs, you can see there's only one output there, and it's for the indication of the e-stop. That's the output which we will use later on. Okay, so now we can go to the cabinet unit. Of course, there's no program there, so it's an empty unit. First of all, we can make like a small description what we are doing now. For example, we are doing the e-stop function. Now we insert the memories, and in this case references. So we got our e-stop from door 1, e-stop from door 2, and the same with the reset buttons. Of course, now we can discuss if it's better to make the reset function on the door units itself or do it on the cabinet unit. But in this case, we do it on the cabinet unit, and you are able to reset from both doors the whole reset function. Okay, yes, so now we have used an AND block for the e-stops and an OR block for the reset. This block is for resetting. So the reset function itself has 4 contacts. Of course, the input, the e-stop itself, or the safety function. Could be also like a door switch or something else. And the reset input for the reset buttons, the output which will be set if you reset it correctly. In this case, we connect the relay output, which gives the e-stop potential free to the machine. And another one, the lamp output, which is an implemented function to switch off and on the lamp of the reset. So in this case, we call it reset lamp. We make it global. And now we can use it to show the status of our reset block on the reset buttons. Okay, so now our reset function or our small safety function is finished, and we can check it by simulating. Both e-stops are there. For example, if I press e-stop on door 2, it should be gone. If I release it, it's back. And now you can see that the lamp of the reset button shows us that the block is ready for reset. So we can go back to door 2, press the push button, and now of course nothing happened at all. But if we release the push button again, then the safety function should be fine and the relay output is there. So next we can download the project. We go to project, edit ID numbers, and can write down the ID numbers. You can find these ID numbers on your simplifiers, on the side of the simplifiers. which is an individual number like a MAC address, which is used for identifying the simplifiers exactly. You can write them down. In this case we have the 3 simplifiers, so we also got 3 ID numbers. If I press OK, I can double check, and now I can download. First of all, it compiles and gives me a check number for this project. Then it asks again if the ID numbers are right. If I say yes, it asks me which way of downloading I would like to use. So in this case, I use radio. In this window, you can also scan the network and see which channels are already used. In this case, our own system uses channel 5, default channel, and 2 other systems, which are here in our company, are using channel 8 and 10. So we shouldn't use them. And you can also set a new radio channel if you would like to. But in this case, we keep channel 5. We'll say OK. Then it's trying to get connection to the simplifiers and downloading the project. In this case, this goes very fast because I was connected to the units before. If you do it for the first time, it maybe takes some more seconds. Also, if there's a firmware update, it also updates the firmware while updating the software or the project to the simplifiers. So this happens in the same download. Okay, if we have downloaded the software, we can go online and see if it works as it should. If I press eStop on door 1, of course it should go off. If I press eStop on door 2, of course it should go off. And in this case, if I press the reset button on door 1 and release it, the safety function should be there and the machine is allowed to run. And of course, if I press an eStop now, the relay output goes off again. There is one function on every page, so it's like a small window down below where it says not verified. If you make a right click, you can say mark page verified, and if you do that, it asks you again if you really want to do it. Then it just say, okay, this page was verified by the user on that date. You can use it for checking your project if you have finished it, and then you know nobody has changed anything since I have verified it. You also get a checksum, of course, for every page, which is a good function because if you have a large project and only one eStop, for example, comes in addition, then you have to make the whole software validation again because only one checksum has changed, or you don't know where something has changed, so you have to validate the whole project again. And with the checksums on every side, you are able to just change or check again the checksum on the pages where something has changed. What's also good is the report. For that, I'm just giving the eStops an identifier. In this case, we just call it door 1 eStop, and also eStop on door 2 gets a name, and also our output gets a name, eStop function, or yeah. So we also can give the eStop output, the relay output, an expected usage. If you do that, the PFHD value will already include this kind of information, so it will be more exact or precise. So now we can print the report. You get some common informations like what are the timeouts, what is the radio frame time, and you also get 3 messages. In this case, you have 3 pages which are not verified, so it's not a problem. But of course, if you have every page verified, then you know, okay, my project is valid and I have checked it. So, and then comes the hardware configuration. We have used 4 IOs of the 14, 2 global memories of the 16, and of course also the pages which we have made. The same for the door 2, and on the cabinet unit we have the eStop function relay 15 and the reset lamp, which goes out as a global memory. So of course the project is very small and simple, but yeah, it's good to see how it works. On the page where we use an output, you get some kind of I/O matrix or some kind of I/O dependencies where you can see which input affects which output. So in this case we have 2 eStops on node 1 and node 2, and they are combined affecting the relay output on node 3. So that's good for making the safety validation to check if every e-stop which is in the system is connected to the right output. And also you can see the PFHD value here, which is calculated from the input to the output, and you can use it directly, for example, for the safety calculation in Systema or in some other tool. One important thing is also, in this case we have only 3 units, so it's no problem to keep an overview about the logic. But there's a sentence which is important to keep in mind if you program wireless systems. Always make the logic where the output switches something off. So the reason why this is important is that, for example, if you set a memory here, the e-stop door, and you put it together, for example, with this memory here and create a new memory. For example, we can of course also put the 2 e-stops here together and use this memory, set it global, and use this memory in the cabinet unit like this. So this is basically the same signal like this. So we could also do it like this. But this has one disadvantage, and that's the jump in the radio. So the signal from door 1 is not directly repeated to the cabinet unit. It first goes to door 2 and is combined with the door 2 e-stop, and then you send it to the cabinet. So we have a loop in the radio, which is of course not so good. In this case it wouldn't be a problem, but it's always good to avoid loops like that. So always make the logic where you switch off. If you have now a simplifier, we can, for example, add one more node, which is a blank unit. We call it door 3. And we make it pretty much the same as the other 2 units. And of course, now the project is also empty. So now we can program it. And we use an e-stop as an input. We give it the pin numbers 2 and 4 because that's where always our e-stop is connected to. We put in a push button, use pin 8, so 2 and 4 for e-stop, 6 for the indication of the e-stop, 8 for the first push button. And then we use 2 memories. One is the e-stop door 3. You make it golden and give it a global memory number. And the reset door 3 is blue. We do the same, we make it global and give it a memory number. So and now we have implemented this, or now we can implement this unit into our cabinet. So what we do is put another reference and use door 3, and we use the reset of door 3 as well. Make the blocks here a little bit bigger with 3 inputs, and we have included the node 4 as well in our safety function. It's very easy to implement new functions or new doors, for example. If the project changes slightly, then yeah, it's very easy to extend our existing program. So now at the end, thank you for your attention, and if you have any further questions, please don't hesitate to contact us.